Hello, this is Coach Holmes, and today we're going to be talking about conditional statements. All right. Now, this is where we're actually going to talk about logic. Okay. This is the basic form of logic, and a lot of the geometry will be based on logical thinking. Okay. Matter of fact, math is logic. If you really think about it, math is pretty much logic. Now, so first off, what we're going to talk about is what is a conditional statement. Okay, is a logical, gotta make sure I spelled it right, logical statement that can be written as a if-then statement. So basically what it's talking about is you say, if something happened, then B will happen, okay? If this happens first, then B will happen next, okay? That's basically what an if-then statement is. Now, typically, you're going to see it as if, then Q, okay? Where the arrow right here is pretty much tells us a if-then statement, okay? Which basically, if P, then Q, okay? That's typically what will happen. If P, then Q. I'm just going to get rid of this, okay? That's typically what it tells us. So, now, so first of all, what is P and what is Q? Well, P is the hypothesis. Or the if statement. Okay? So whatever the statement that describes if, so whatever the statement that comes after if, that's the hypothesis. Now the Q, however, is the conclusion. Or the then statement. Okay? So this comes after then. The conclusion comes after the word then. Just like how the hypothesis comes after the word if. Okay? So, I'm going to change this in blue real quick so that way we don't get them mixed up. So next we're going to underline the hypothesis and we're going to circle the conclusion. Okay? So again, I'm looking for the hypothesis, I'm looking for anything that comes after if. Okay? So if a polygon is a triangle, then the sum of its angles is 180 degrees. So obviously, I'm looking at it, I see the word if. So as soon as I see if, I'm going to circle the very first thing it comes after. Underline, not circle, underline. So, the statement, the hypothesis is a polygon is a triangle. That's it. Next, we're going to circle the conclusion, which remember, it comes after then. So the sum of its angle is 180 degrees. So the conclusion for the statement is the sum of its angle is 180 degrees. That's the then statement. Okay? Now, let's try this again. If the animal is a poodle, then it is a dog. Okay? Again, I'm just worried about underlining the hypothesis and circling the conclusion. So that way I know what is the hypothesis and what is the conclusion. Remember, right after if, we're going to underline the statement, which happens to be the animal is a poodle. And the conclusion, which comes right after then, it is a dog. So the conclusion of the statement is, it is a dog. It's just simple as that. Okay? Now, one thing about logic is, is it true? You know? So when it comes to if-then statement, there's a typical way of determining if the statement is true or not. So here's an example. This is an example I want you to think about. You don't have to write this down. Matter of fact, I'll put it in green so that way you just know that don't write this down. If, and I want you to think about this type of if-then statement. If you pay rent early, I'm sorry. Then you get a discount. So this type of situation is where I am not writing it. There we go. This is the type of situation where the if-then statement really becomes, is it true or not? This is where it matters. So for example, if we say true, that means you did your part in paying the rent. And if it's true in the conclusion, that means you get the discount. If it's false for the hypothesis, you did pay your rent early. And if it's false for the conclusion, you don't get a discount. Okay? So the false is pretty much the opposite. So basically, think about this in fairness. Is it fair that the results happen in that way? Now, for example, if you pay rent early, which is true, so you pay the rent early, you get a discount. And that happens to be true. Well, of course, if you pay rent early, you get a discount. That's obviously true. That's fair. Now, let's say you pay rent early, but you don't get a discount. Well, that's not fair. You did your part, right? That's what makes it false. Because it's not typically fair or it's not logical to follow in that direction. Especially when you already fulfilled the if statement. Now, you don't pay rent early, okay? So now we're getting to the point where, okay, as you don't pay rent early. If you don't pay rent early, then you get a discount. Well, I mean, that's definitely true. Because there's nothing wrong with that. That's just the landlord or the guy you pay rent to being generous with you. Okay, like, okay, you didn't pay early, I'll give you a discount just for this one time. You know, that could, you know, that's logical. That's okay. The landlord has every right to give you a discount. Has every right to give you a discount if you don't pay it off, if you don't pay the rent early. You know, he could be generous. Now, if you don't pay rent early and you don't get a discount, that's fair, which makes the statement true. And the reason why it's true, and I know what you're thinking, it's like, well, if it's false to false, shouldn't it be false? It makes sense. I understand the confusion. But here's the thing though, you didn't pay rent early. So what should you expect? If you don't pay the rent early, you should expect not to get a discount. Okay? But what about the last one? Why is it false to true? Well, he's not obligated to give you a discount. He's just saying, okay, I'll give you a discount. No worries. Okay? So if it goes true to true, the statement is true. If it goes true to false, the statement is false. If it goes false to true, the statement is true. But if it goes false to false, the statement is true as well. Okay? Now, which by the way, I want y'all, even though I put it in green, I still want y'all to write down those truth statements. Should have kept that in mind. Okay? Now, so now let's practice with some of these. Let's practice and figuring out whether or not the statement is true or false. So determine if the statement is true or false. If dogs can fly, then pigs can fly. Okay? So obviously dogs cannot fly. If then pigs can fly. Well, that's not true either. So if it's false to false, looking at our tables right here, if it's false to false, the statement is true. Now, a statement like this doesn't really make any sense at all. But when it comes to truth values, it is true. If a rectangle has 4 angles, then it is a square. Okay, so typically if if we draw a little rectangle right here, it does have 4 right angles, right? So the if statement is true. However, if I do the then statement, it's saying, well, it's a square then. Well, think about it this way. Besides having 4 right angles, a square has to have 4 equal sides. Rectangle doesn't necessarily have to have 4 equal sides. So that statement is, so the then statement is false, which means that this statement is false. Especially when we look at our table, we look back at our table, true to false gives us a false statement. So now, if blue is a fruit, then orange is a color. Well, that's not really a fruit. That's not really a fruit that is blue. Matter of fact, blue is not typically a fruit. But but the then statement says orange is a color. Well, orange is a color. So if we go look at our tables again, if I go from false to true, then the statement is true as well. So that statement is true. So really, when it comes to if-then statements, the only time that a statement is false if it's from true to false. Okay? If it's from true to true, the statement is true as well. However, if it's false to false, the statement is true, contrary to popular belief. But if we go from false to true, the statement is true as well. Okay? So just be aware and look at your tables to understand whether the statement is going to be true or false. Thank you and have a good day.